Today we will be talking about 5.4 future and present value. Future and present value really is just an extension upon the previous ways that we compounded money that we had talked about earlier in this semester. So as a reminder, we talked about the equation A of t equals P times e to the RT. This is the way that we can calculate compounded annually interest. In this situation, we have our money in two forms. We have money all at the beginning, and that is our principal. So that's all the money we start with. The amount of money we end up with is called our annuity. And so it basically, if we want to think about this equation in a different frame of mind, this equation relates the present value or the starting amount of money to our future value or our ending amount of money. So an alternative way that we can write this expression is FV for future value equals present value times e to the RT. And this equation will represent how much an initial deposit of funds would relate to the amount of money we would end up with after X number of years. So let's do an example real quick before we talk about this new idea today. So let's say we start our present value with $5,000 and our investment is at 5%. So 5% is 0.05 and our time for our investment is 25 years. So the way that we can read this is we are investing $5,000 for 25 years at a return rate of 5% or 0.05. If we want to figure out what our future value is, we just plug all this information into our formula just like what we've done before. I just want to do another example with you all since these letters are a little bit different. We're switching from terminology of future value and present value to the terminology, or switching from principal and annuity to present value and future value. So we just plug all this information into our equation. So we do 5,000 e to the 0.05 times 25. And as long as we type this into our calculator correctly, we get that a $5,000 investment after 25 years at 5% interest is equivalent to $17,451.71. So just an example as a quick refresher of what we've done in the past. Now, typically, if you're trying to save money, you're not going to just invest a certain amount of money at the very beginning and let that money sit and don't do anything with it, don't add to it, don't take away from it or anything like that. So the new idea that we're going to be talking about today is called an income stream. And then since we're using a stream, we're going to use the letter S to represent income stream. An income stream is kind of like an initial investment, but we don't just make it one time. We make it continuously every single year. So for example, instead of investing $5,000 at the beginning of a year, we may be investing $5,000 every single year and accruing interest that way. Okay, so we have three different ways that we can talk about money. We have our present value, which is the amount of money we would start with. We have our future value, which is the amount of money that we would be ending with. And this new idea called our income stream, which discusses the idea of incrementally adding money every single year throughout the years of your investment. So for this, again, for the second option, or for this third option, income stream, it's like we invest $1,000 every single year. What would the end result for our future value be? That type of idea. So we have equations for these, just as a refresher. We have future value equals present value times e to the RT. And then we have an equation that relates future value to income stream. That is the integral from 0 to a of S times e to the RT dt. So very similar. And we have our present value formula, which is almost the exact same formula, except instead of e to the RT, it's e to the negative RT. Write that a little neater. So before we only had one equation that related present value to future value. Now we have three equations that relate present value, future value, and income stream all to each other. So let's go ahead and do an example and see how it goes for us. So we are going to start off by saying we plan to invest, say, $500 every year. Now, we are saying that we're doing this investment every single year, so we should automatically know that that $500 is an income stream. We're going to ask two questions. Let's finish this first. We plan to invest $500 every year. We expect a 6.5% return on investment, or 6.5 annual return on investment. So essentially, this means that our rate of money is expected to be 6.5% each year, and we do this investment for 15 years. So we plan to invest $500 every single year, and we expect 6.5% rate of return, and we do this for 15 years. So essentially, we're investing $500 every single year. That's our income stream. Our rate is 0.065 or 6.5%, and the time length that we're doing this for is going to be 15 years. Question 1. How much money will we have after 15 years? And question 2, how much of an initial investment would we have needed to make to have an equivalent amount of money? So question 1 wants us to take our income stream and figure out what ending amount of money or what future amount of money is equivalent after 15 years to investing $500 every single year. Question 2 is a little more abstract because it's kind of like a hypothetical situation. We want to hypothetically figure out what would an initial investment need to be in order to result in the same amount of money. So essentially, question 1 is asking for the future value that is equivalent to investing $500 each year. And question 2 is asking what is an equivalent present value for investing $500 every year for 15 years. So let's go ahead and get started with question number 1. Again, our income stream is going to be $500. Our rate is going to be 0.065, and our time is going to be 15 years. We want to be very careful with that time. We'll talk about that in a second. So, and the thing that we want for question 1 is our future value. So if you rewind the video, you will want to find which of those 3 equations relates income stream to future value. That equation is going to be future value equals the integral from 0 to a of our income stream times e to the rt dt. Now, the reason why we have to be careful with this time is this time actually does not refer to t here. T is kind of a variable. T represents all the years. So T represents the first year that we're doing this, the second year, the third year, the fourth year. It represents all of those years. So time in this situation, our 15 years, actually is not going to be 15. 15 is actually related to our A value, which is our ending time. So that's something we haven't talked about yet. So let's make sure that that's clear. A is going to be what 15 is equal to, and A represents our ending time. It's very easy to make the mistake of plugging 15 in for t. I completely understand why you think that. But again, in our integral, t represents all the times from 0 to a, not just the ending time. So whenever we're finding a time using our income streams, that time that our investment is in there for represents a, not our t. So make sure you plug it into the correct spot. So if we plug it into the correct spot, we have 0 to 15 times 500 e to the 0.065 t dt. So again, big deal. T stays as the variable t. We do not plug anything in for t. Instead, we plug our time in there for our bounds. If we do that correctly, this is the equation that we will have set up. And now all we need to do is use our calculator to figure out what this equation is equal to. So the integral of 500 e to the 0.065 t from 0 to 15. And we get that this investment of $500 each year is equivalent to ending up with $12,701.29, which is pretty cool because actually in total we are investing $7,500, but because of interest, that $7,500 of total investments ends up resulting in $12,700. So that's answer to question one. Question one again was how much money will we end up with after 15 years? So we're relating our income stream to our future value. For number two, how much of an initial investment would we have needed to make in order to have an equivalent amount of money? This is asking us to compare that income stream to an equivalent starting value. So it's asking us to compare our income stream to a present value. So for number two, we have all the same starting information. S is 500, R is 0.065, and A is 15 years. But now, instead of wanting to find future value, we want to find our present value. So we need to go all the way back to the beginning. Go ahead and rewind the video if you didn't have it written down. And we need to discover which of our equations relates present value to income stream. That equation is PV equals the integral from 0 to a of S e to the negative RT dt. And again, just like we talked about for the last example, we do not plug our time in for t. T represents all the time from 0 to a, so it represents all the years from 0 to 15, so we do not plug in for t. Instead, we plug that time value into our bound. So we're going from 0 to 15 of 500 e to the negative 0.065 t dt. And now we have our equation that will be relating income stream to present value. We use our calculator to do this integral for us. We're doing the integral of 500 e to the negative 0.065 t evaluated from 0 to 15. And we get $4,790.83. So for this example, investing about $4,800 up front for 15 years is equivalent to investing $500 every single year. So it's that relationship. So with this section, a lot of what you're going to be focusing on is finding out which two concepts of money are we trying to relate. Are we trying to relate present value to future value? Are we trying to relate present value to income stream? Or are we trying to relate future value to income stream? Those are really the three options that we're working with. And as you practice, you'll get better and better at identifying which of those pairings we'll be working with. And once you have the correct pairing of ways we describe money, That will help determine which of these three equations you'll want to be working with.